This is example 11.4 from Discovering Design with Chemistry. A chemist would like to neutralize a 3.4 molarity solution of HBr. If there are 312 milliliters of the solution, what volume of a 2.0 molarity NaOH solution would have to be used? So we're relating one thing to another and talking about a reaction. A neutralization is just a reaction between an acid and a base. So let's go ahead and start by making a chemical reaction, like a chemical equation, and then we'll start labeling things. So we want to have HBr, that's our acid, we know because of this H at the front. We're going to neutralize it with NaOH. And then to finish our chemical formula, we have to figure out what's happening here. So these are going to turn into our H2O, and we'll be left with NaBr. Now, let's just check real quick to make sure that we've got it right. So Na is in the first column, Br is in the seventh column, so those each have a +1 and a -1 charge, so they are just fine the way they are. We were given the other two. We know H2O, so our subscripts are all right. Let's check to make sure our in front of numbers, our coefficient numbers are right. So we have 2 H's on the left, 2 on the right, 1 Br, 1 Na, and 1 O on the left, and 1 of each of those on the right. So our balanced chemical equation is good. So let's start labeling things. So we know that our solution is 3.4 M. And remember, when we're talking about molarity, which is what the big M stands for, that formula is the number of moles divided by the liters. Okay. And then we also have that, let's see, if there are 312, so 312 milliliters. Let's go ahead and change that into liters, so 0.312, because it's nice to know what we have, but we need it in the right unit. And then we want to know the volume, what volume of NaOH. So we know it's a 2.0 molarity, but what we don't know is the volume. So that's what we're trying to find. The good thing is they both have this imaginary 1 in front. So when we're working with these, what we're asking for is liters, and we know the molarity. Our chemical equation, though, relates moles to moles. So let's go ahead and start converting some things over to moles so that we can figure out what we've got. So we can use these two numbers here. We have, let's squish this up a little bit. All right, so we have molarity equals moles divided by liters. Well, we have molarity, we have liters, what we want is moles. So what we're going to do is we're going to rearrange this thing. We're going to take the L and multiply it by both sides so that it cancels out, and then all we're left with on this side is moles. And in fact, I'm going to change my L. Instead of writing an L, it is in liters, but I'm going to put volume over here. All right, so 0.312 times 3.4, and that'll give us how many moles we have of this HBr. All right, so we can only keep two significant figures, so that's going to be 1.1. So we have 1.1 moles of the HBr. Now, we could do our little conversion thing where we say we have, for every 1 mole of HBr, we have 1 mole of NaOH according to this chemical equation. And then we could take this number that we just got and we can multiply it by this conversion factor. But we can see that we're going to have 1 over 1. And so I'm going to just go ahead and spoil the surprise and tell you that we've also got 1.1 moles of NaOH involved in this neutralization. And so if we want to know what volume we have and we know what the solution has as far as molarity, meaning how many moles do we have of NaOH in each liter, we can use the number of moles that we need, use the molarity, and find that L. So this time we have M equals moles divided by liters, and this time we have the molarity, we have the moles. What we don't have is our volume. And so to do that, I'm just going to switch these two numbers here. I'm going to multiply both sides by L, so that L ends up over here by itself. And then I'm going to divide both sides by the molarity, so we end up with the M down here by itself. In previous videos, I've pointed out this is a pretty basic algebra rearranging of a formula. So I'm not going to work through how to do that. Alright, so let's plug in what we have. We want volume, so we don't need to plug in anything for the L because that's what we're getting. We have 1.1 moles, and then our molarity is 2.0, and that's moles per liter, which means this and this cancel, and we're going to be left with the liter on the top because it's on the bottom of a bottom. So 1.1 divided by 2.0, we're going to keep two significant figures, which is all we have anyways. So 0.55 liters. So we need 0.55 liters of the NaOH solution so that we can neutralize the HBr. And we can, because this is kind of looks like a weird number, we can also change it to milliliters by moving that decimal. So this is the answer, but this is also okay. Either one of these would be right. And the 550 milliliter still has two significant figures, so that's fine. All right, so that's the answer to this particular problem.